Okay, here in section 4.5, we're going to learn to take a polynomial and multiply it by a monomial, which is going to require that you use all the rules that we learned in 4.4, 4.3, and then some of the rules that we learned in 4.2 as well. Multiplying a monomial and a polynomial. Take a look at the first example here. So the polynomial here is a trinomial, 2x squared minus 8x plus 5. And the monomial is 3x squared. So what we're going to do is we're going to take the monomial and we're going to distribute it to each of the three terms in the trinomial. And when we do this, now this is going to be using the rules from earlier in chapter 4. 3x squared times 2x squared is 6x to the fourth. Multiply the coefficients, and then in this case we add those exponents. Distributing to the second term, I get negative 24x cubed. Now remember, there's an understood 1, which is the exponent of that x. And when I distribute it to the third term, 3x squared times a positive 5 becomes plus 15x squared. And that's it. That's it. You just distribute that monomial to each of the three terms in the polynomial. Okay? Let's try another one. Just a little bit more involved here. There are more than one variables. There's a fraction involved, but the concept is the same, gentlemen. Distribute this to the first term. When I distribute this to the first term, negative 3/4 times 8. Do a little cross-canceling. Think of that 8 as 8 over 1. When you do the cross-canceling, that 4 would go into that 8. 2 times the negative 3 leaves you a negative 6. And then when you multiply p cubed times p to the first, that gives me p to the fourth. Q to the first times q to the third gives you q to the fourth. To the second term, multiply the coefficients. Negative 3/4 times a negative 4 becomes plus 3. P cubed times p squared is p to the fifth. Q times q squared is q cubed. Distribute one more time to this last term. First, multiply the coefficients. Negative 3/4 times a positive 20. The 4, the denominator, goes into that 25 times. Multiply the 5 times the negative 3, that becomes negative 15. Multiply the p cubed times the p cubed, that gives you p to the sixth. And then q times q is q squared. There you have it. That's the concept, gentlemen. Simply multiplying a monomial times a polynomial requires distributing. Let's put some of our concepts together here. Let's simplify this expression. Simplify. So following order of operations, let's work inside the brackets, and inside the brackets I think what I'll do is I'll distribute this negative 3 to start. And when I do that, I get a negative 3 plus 3m. At this point, the temptation might be to distribute that m, which you could do, but I think we'd be better off to simplify inside the brackets by collecting the like terms first. Collecting the 2m and the 3m, or combining them, gives me 5m minus 3. Now distribute the m inside the brackets. M times the 5m gives me 5m squared. And then m times the negative 3 gives me a minus 3m. Follow order of operations. Same thing here, just a little bit more involved. Simplify. Inside the brackets, I think we should probably distribute the negative 2 first. Rewrite the 4x, rewrite the open brackets, rewrite the 9x. Now let's distribute that negative 2. I get a negative 10 minus 6x. Collect like terms inside the brackets. The 9x minus 6x we can combine. That becomes a 3x minus 10. Now let's distribute that 4x inside the brackets. I get 12x squared minus 40x, and then minus 7x squared. Lastly, combine these like terms, and I get 5x squared minus 40x. Okay? There's a couple more here. Now this is an equation. Look, we're solving. Let's solve this equation for g. Now this is going to involve the concepts that we've just learned, multiplying a monomial and a polynomial. So we're going to distribute here, and we're going to distribute here as well. So let's do that to start. When I distribute that g, I get 2g minus 3g squared. When I distribute the 3, I get plus 3g squared minus 12 equals 0. So if we collect like terms, check this out. Those are the like terms, but when I combine them, I get 0. So I'm just left with 2g minus 12 equals 0. Add 12 to both sides. 2g equals 12. Divide both sides by 2, and I get my solution of g equals 6. So again, what does that mean for 6 to be the solution of this equation? 6 is the only number you can plug in for g in the original equation to make that a true statement. Okay? Last problem. Find the area of the shaded region. Find the area of the shaded region, which is yellow. So let's think strategy here. Those are two rectangles. If I want to find the area of the shaded region, I think the best approach would be to take the area of the big rectangle and subtract the area of the small rectangle, which would leave me with the shaded region. So remember, the formula for the area of a rectangle is length times width. So the expression for the area of the big rectangle would be length times width. There's your length, there's your width. So it's 4x times 7x plus 5. We'll write big right above it. That's the area of the big rectangle. And then remember what we said we'd do. We'd subtract the area of the inner or small rectangle, which have dimensions 2x and 3. So to find the area, we'll take the length, we'll take the length times the width of that inner rectangle. So 2x times 3. And that's the area of the small rectangle. So this right here, this is the expression that represents the area of the shaded region. Now let's just clean this up. Now look at what we have to do. To find the area of the big rectangle, let's distribute the 4x to the 7x plus 5, and I get 28x squared plus 20x. And then let's subtract the area of the small rectangle. 2x times 3 is 6x. And when I combine these like terms, I get 28x squared plus 14x. There is the expression, simplified, for the area of the shaded region in this diagram. Guys, I hope you understood everything. This is 4-5. Your homework, which will be due on Monday, is right here. From 4-5, do 3 to 39 multiples of 3, and do 40 and 42. So I'll see you guys on Monday. Happy Halloween, and good luck with this 4-5 homework.